Hello student, let's solve the problem. An infinite number of charges, each of charge 1 microcoulomb, are placed on the x-axis with coordinates x is equal to 1, 2, 4, 8 and dot 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 into up to infinite. If a charge 1 coulomb is kept at the origin, the net force acting on 1 coulomb charge is. Okay, so first of all let me draw the coordinate system. This is x-axis and suppose this is our origin, and at the origin a 1 coulomb charge is situated, and at x is equal to 1, 2, 4, 8 and so on up to infinite 1 microcoulomb charges are placed. Correct. So suppose this is x is equal to 1, this is 2, this is 4, this is 8. In this fashion up to infinite there are 1 microcoulomb charges are placed. Okay, and we have to find the net force on the 1 coulomb charge. Correct. So we know that force F is equal to a force on a charge q. If the net electric field at that point is E, then F is equal to QE. As the charge value of the charge is 1 coulomb, so the force is nothing but the electric field at that point, right? So basically we have to find the net electric field due to the charges at x is equal to 1, 2, 4, 8 and so on up to infinite. So what will be the net electric field due to the charges? That the value will be 1 by 4 pi epsilon naught times the charge. What is the value of the charge? Suppose q prime, and the q prime is equals to 1 microcoulomb, and the distance is inverse to the distance square, that is 1 by 1 square, 1 by 2 square, 1 by 4 square, 1 by 8 square, dot 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 up to infinite. Correct. So the value of the charges are 10 to the power minus 6 coulomb. So I write it here 10 to the power minus 6 by 4 pi epsilon naught, and it becomes 1 plus 1 by 4, 1 by 16, 1 by 64 and so on up to infinite. So this is a infinite series, right? This is a infinite series, and infinite infinite series. Okay, we have to find the value of this infinite series, and the series you see this is basically a GP series. Correct. And in case of a GP series, the sum is nothing but a by r minus 1, where the a is the first term, and r is the common ratio. Correct. So let's put the value of the a and r. Here the first term is 1, so a is equals to 1. And what is the value of r? See, 1, if we multiply 1 by 4 with the first term, then we will get the second term. Correct. Similarly, if we multiply 1 by 4 with the second term, we will get third term. Similarly, if we multiply 1 by 4 with the third term, we will get fourth term. So r is the value of the r here is 1 by 4. Okay, by mistake I have written here the mistake, wrong thing. It will be 1 minus r. Correct. So 1 minus the value of r is 1 by 4. Let me erase this. If I erase this, then what we will have, see 1 and here 4, 4 minus 1 3, that is it becomes 4 by 3, correct. So the value will be 10 to the power 6 multiplied by 9 into 10 to the power 9. You know the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9, and the value of this infinite series, sum of this infinite series is 4 by 3. So what will be the value of this if we calculate it? The 9 divided by 3, that is 3, and we have to multiply 3 with 4, that is 12. 12 into 10 to the power minus 6 into 10 to the power 9, that is, if we subtract 6 from 9 we will have 3, that is 12, and 3 zeros after 12. So this is the net force that will be experienced by the 1 coulomb charge situated at the origin. So our correct option is option 2.